Hi, my name is Katie Garcia, and this is my video presentation for Lab 1 on the charged tapes for Physics 2. So today we're just going to do a quick introduction to today's lab and then cover an observational model or experimental model, and then look at a computational model which is done through GlowScript code, and then we're going to conclude. So for the introduction, first we're going to talk about the purpose of today's lab, and that is to use two pieces of tape to create an electrical charge through the transfer of electrons between the two tapes, and then we're going to observe its effect or its reaction with different surfaces and then calculate the value of this electrical charge. Then we're going to do the same through a GlowScript code and produce a computational model of this same exact lab, and look at the two charge tapes exerting an electric force on each other. So for the results of today's lab, I concluded that the two pieces of tape repulsed each other after being charged, and so therefore the charge was determined to be positive. So a couple main physics ideas and important information are, first of all, the formula for the electric field, which is force equals the electrical charge times the electrical field. The electric field on an external location due to charge Q, which is given by K times Q divided by the magnitude of the relative position vector squared. And then the force of gravity is also important. I also want to identify the system, which is tape A and tape B, and the surroundings, which is everything else, including my hand and the air. So for the experimental model, I think it's very important to mention that the initial conditions for this experiment were that the tapes were neutral. They had absolutely no charge to begin with. So this was done by charging a piece of tape by placing another piece of tape on a desk and placing that tape on top of the other one and ripping it quickly, causing the electrons to be transferred from each initially neutral tape. So the newly charged tape was then hung at the end of the desk to see its interaction with my hand, and it was hung near multiple objects, including a book, a pen, and it was finally placed on above another charged tape. So a couple observations were that the tape was attracted to my hand, the neutral book, and the negatively charged pen, but it was repelled by another charged tape. So I was able to conclude that the tape was positively charged as a result from losing its electrons, because it was attracted to the negatively charged pen, and since opposites attract, we were able to conclude that it was positive. A couple calculations in data, you can see the length, width, and mass, and then distance and the force of gravity. On the bottom, where I calculated the charge Q, I simply set the electrical force equal to the gravitational force, because we're assuming that there's no acceleration and therefore they must be balanced, and then I just solved for Q. A couple other things I calculated were the number of electrons lost, which I did by dividing the charge of the tape by the charge of a single proton, the area of the tape, which is the tape length times the tape width, the area of an atom, which is the length of an atom squared, the number of atoms on a piece of tape, which is the area of tape divided by the area of an atom, and then the ratio at the bottom. So for the computational model, I had to make the assumption that all of the charge on the piece of tape was concentrated at the center, and therefore I had to treat it as a point mass and assume that each U-tape that I made throughout the experiment had about the same charge. So on the left, you can see the GlowScript code. At the top, I'm giving values to each of the constants, which are just data that I got from my experimental model. And then for the calculations, I'm doing the same exact calculations I did for the experimental model. And on the right, you can see that the charge of one piece of tape is roughly about 1.4 times 10 to the negative 8 coulombs. So a couple of final questions are, what if the electrons had a positive charge and the protons had a negative charge? What would change in the observations? Well, the results would have been the same, because if the positive and negative charges would have been swapped, the like charges would have still repelled and opposites would have still attracted, which is what happened during this experiment, and which is what would have happened if they were swapped. So why is it important to handle the charged tapes as little as possible? This is because any contact would have neutralized the tapes. So any electrons that are transferred, either removed or added to the tapes, would have further neutralized it and jeopardized the data.